some more properties, some more criteria for congruence of triangle. The first thing is SSS congruency. As we discussed earlier, S stands for side. So, the sides of a triangle are equal to the sides of the other triangle. Corresponding sides are equal. Then we can say the two triangles are congruent. For example, this triangle ABC as usual and this triangle DEF. In that, see, previously we have seen right in the first session itself, all the sides should be equal, all the angles should be equal. So, all the sides are equal means it is enough, we don't need to check the angles, angles automatically will be equal. That is what this criteria says. So, suppose if I am saying AB is equal to EF, AC is equal to DE and BC is equals DF. Then, since the corresponding sides are equal, we can say this triangle ABC is congruent to triangle. See, this also like the same we have to write. AB is equal to which side? EF. And BC is equal to DF. That is it. Then if you take all the congruency will come. AB is equal to EF. And then BC is equal to FD. And ED is equal to AC. Okay, like the same, we have the another congruence rule, RHS congruence. Here two new alphabets are there, R and H. So that itself states that this congruence can be only applied in right angle triangle. Which triangle? Which triangle, man? Right angle triangles. Two right angle triangles. The right angle and the hypotenuse and a side, any other side, but that should be corresponding side, are equal. Then we can say by RHS congruency, those two triangles are congruent. Okay. Now there is one important examples is there. The example 7. Figure is given for this, but even though we will try to draw this figure and try to understand. See, AB is a line segment. AB is a line segment. P and Q are points on opposite sides of AB. P and Q are points on opposite sides of AB. Such that each of them is equidistant from the points A and B. Each of them is equidistant. The distance from A and B to that points are equal. Okay. Show that the line PQ is the perpendicular bisector of AB. This line PQ is perpendicular bisector of AB. We need to prove. This has two parts of proof. First we will prove it bisects, then we will prove it is bisecting at right angles. Okay. So given what we will write, PA is equals PB, and then AQ is equals BQ. Okay, and then we need to prove these two halves are equal. How we can prove that two halves are equal? For that, we should need, see, this two we can take, but for that we should need these two angles should be equal. If these two parts are equal means we can say, then by this SSS congruency we can say these two halves are equal. But we don't know these two are equal or not. For that, I am going to take first we prove this triangle APQ is congruent to triangle BPQ. Okay, why? To get these two halves of the triangle equal. Also, before that we need to write this point of intersection. Let M be the point of intersection of PQ and AB. I am naming this point as M. Okay. So, in the question itself it is given that AP is equals BP. We have AP is equals BP, and then PQ is the common side. It is common. It is given. The other way, the other side AQ is equals BQ also given in the question. Then by what congruency we can apply? By SSS congruency. We have triangle APQ is congruent to triangle BPQ. Then we have this angle APM is equals angle BPM. Actually APQ and BPQ, that implies APM and BPM. This comes by CP. Okay, we will mark it as 1. This should be useful. Now in these two triangles APM and BPM, in triangle APM and triangle BPM, we have the side PM is common, PM equals PM, it is common, and then AP is equal to BP, that we know earlier. Given, and shall we say AM is equal to MB? No, that only we have to prove. Okay, then the remaining part is from 1. I am naming it as 1. Then we have angle APM equals angle BPM, that is from the first equation 1. Then by what congruency here? Yes, AS. He said two sides are equal and the angle lies between the two set sides. So by SAS congruency, we have this triangle APM is congruent to triangle BPM. Then we may have AM is equal to BM by this CP. Have you proved that? Therefore, PQ bisects AB. But this is not enough, sir. We proved that PQ is a bisector. What makes it perpendicular? We should prove this angle is 90 degree. How to prove this angle is 90 degree? Any guess? See boy, these parts are equal, you know that or not? How? APM and BPM are congruent, means what? This is corresponding angles of the congruent triangle, okay? So, and also we have angle PMA, Ratan Mandri Awas Yojana, PMA and PMB are equal by CP and also I written and we have this PMA plus angle PMB equals 180 degree because they are linear pair. So therefore angle PMA equals 90 degree because either one will substitute. Instead of PMB I am substituting PMA. 2 times PMA is 180 degree, then angle PMA is 90 degree. That makes PQ is perpendicular bisector of AB. That is it. Quite long proof, is it? Do you have any doubts in this, or you want me to explain this once again? Clear? Sure. Okay then. Then tomorrow we'll be solving the next exercise. Okay.